Everybody, please welcome Yonatan Kra.
Well, I'm very excited to be here for the fourth edition of ConfrontJS. Always a pleasure to be here. Yay, thank you for having me. All for you. Today I want to talk about something you might know, Disney+. How many of you know Disney+? Yeah, quite a lot. Almost everyone. So about almost a year ago, Disney+ got to Israel, and many people complained about this. Anyone know what Dolby Atmos is? Dolby Surround, anything? Anyone?
Problems with sound.
Something with sound, yes. Okay, so this is a technology that allows you to enjoy the sound from movies. Let's say the movie emits a sound from a static speaker, but you'll hear it as if it's coming from all around you. Okay? So if a character goes from here to here in the movie, you'll be able to actually hear the sound moving, but the speakers aren't moving. Okay, so it's an illusion. And this is not a new technology, it's pretty old. This is, anyone knows what it is? Barno. It's different. But yeah, so back in 2007, I started researching the brain of the barnacle, and I needed to set up a system that allows me to let it listen to stimuli from various points in space, and then see how its brain reacts to it. So I could set up a set of speakers like this and emit the sound, and it could work, but setting up a lot of speakers costs a lot of money. I could have built like a robotic arm, but also costs money, and I could use earphones and simulate as if the sound is coming from various places. So how do you do it? Same as the surround technology. You emit the sound from various locations, you record it in the barnacle's ear, and then when you have the two sounds, the original and the one you record, you can extract the filter that the sound is going through from the speaker to the ear. So if you take the original sound, you multiply it with the speaker, with the filter. When you emit it from the earphone, you'll get the illusion, or the barnacle will get the illusion as if the sound is coming from various places in space. I'm sorry. So we actually did that. But this only creates static sounds. How would you create a moving sound? Okay, so if we take like the static points that we measured and we just evoke them one after the other, it won't be such a good simulation because it will just be as if something is here, then it's here, here, and here. We want like the continuous effect that we hear in the movies, right? Otherwise, it won't be such fun. So for this, okay, I kind of lied to you because it's not exactly multiplication. It's called convolution. Anyone doing AI? Convolution? No? No AI convolution? Okay. So, sorry. I'm not getting into the math, but in order to create the continuous effect of motion, what you need to do is interpolate, like create like fake samples between the measuring points, and then you need to convolve or multiply each one with the real example, and then you create a sound that if you just evoke it to the barnacle, it will be like a moving object. Okay, so behind my words that might have been complex, there is even more complex math, so I'm not going to get into it. But the thing is that this algorithm back in 2007, 8, even 2010, took a lot of time to run. There was no cloud, no AWS, no GCP, no nothing. And I usually waited for the weekend when my lab mates left their computers and went home, And I just took over the computers, started one part of the software running on one computer, another part on another computer, and so on. So I had like 3 or 4 computers running all weekend, and eventually I came back at the beginning of next week, and hopefully I had 4 files I could combine and have the sound that I needed for this week's experiment. Anyone knows how you call it in computer science when you split the work between computers? Spark? Anyone? Okay, let's say sharding, for instance. You can use shards. So, yeah, so that was sharding back then. Today, you do it in one click in AWS, and you get like, you can do it. It's fun. But the thing is that sometimes, well, quite a lot actually, I had to change something in the code because I needed to create a new experiment. And I came back at the beginning of the week expecting to find my files, and one or more of the scripts had this red flag error, could not complete the process, or any other kind of error. And that is called a regression. Okay, so a regression can be something very simple. It can be a regression on your laptop. You created some change in your app, and this app, and you saw immediately that a button didn't appear, or a button doesn't work. And it could be something more critical, like my work back then, that work of a whole weekend that I was expecting to use for the next week didn't work. And that's kind of, actually, I was also the developer and the consumer, so I kind of ruined my own week. But your clients, your customers can suffer from this. And this is the worst kind of regression, if your customer finds your bugs for you. This is actually a picture I created for ConfrontJS 2018. Anyone knows this? If debugging is the process of removing bugs, then programming must be the process of putting them in. Okay, a very wise person said that. It's called Dijkstra. Yeah, someone learned computer science. And us as developers need to make sure that our regressions, because we're going to have them, okay? Dijkstra said, we are putting bugs as we develop. But our professionalism as developers is to catch the bugs before someone else notices, okay? And fix them, of course. So if we notice them, it's the best. If the customer notices them, it's the worst. But every step in between costs much more than if we, the developers, don't catch them. Okay, so how do we do that? And that's an open question. If anyone knows how to make sure the bugs are stopped before they leave our computer, can you tell me?
Precise specification and state machine-like languages like Rust. We can prevent from doing this, so it's more than static analysis. And also test what it's.
Okay, so you mentioned things that are kind of like language specific, for instance, but tests, okay? Tests is like the universal way we have to prevent regressions. Because the moment we have a test in place and we run it on every change of our code, then we know that what we had before is still working, or broken if the test fails, okay? So one strange thing is, you don't have to go into this one, I'll just get into it. One interesting thing is that when I send this question to developers, nobody writes test. Okay? You probably say test because that was in the talk's topic, test drive your code. But most people don't think of test when they think of habits that makes them more professional. Okay? And we'll soon see that this is something that, I don't know, I find it strange, and I hope that you find it strange now that I pointed out. And we'll see how software development is much like every other discipline or field, and how we can learn from other disciplines. So who is this guy? Mr. Miyagi. Yeah, who doesn't know Mr. Miyagi, right? I mean, that's how I know when we were born. That's kind of, yeah, or how old I am. So Mr. Miyagi, he was a karate teacher. He taught Daniel-san karate, but he taught him in a very strange way. Okay, he's like the archetype of mentorship. So what he did was he took Daniel-san and he told him, okay, start to paint the fence like this. Okay, and now you need to wash my car, wax my car. Wax on, wax off, wax on, wax off. And Daniel-san did it for a few days. But he wanted to learn karate. So he came to Mr. Miyagi after a few days and told him, listen, you told me you're going to teach me karate. But all I did was wax on, wax off, paint the fence. That's all I know to do. And Mr. Miyagi told him, okay, stand like this. Now do wax on, wax off. And then he's try to punch him, but the wax on, wax off blocked the punches. And suddenly it clicked to Daniel-san that this strange actions that he did repeatedly made him a karate artist, a martial artist, okay? And that's discipline. And it doesn't stop in martial arts. For instance, doctors. Okay, doctors, when they get into the surgery room before, on the preparation room, they have certain procedures. They have to wash their hands, for instance, but not just wash their hands. They have to do it like this, okay? Take the soap, do it like this 5 times, okay? Now do it like this 4 times. 4 times, 6 times, 6 times, wash again, and then put the gloves or whatever. Okay? And it actually differs from hospital to hospital. But the fact is that they have the discipline to do it. Okay? It's their wax on, wax off. And what's the purpose of this hand washing? Yeah. Actually, it's not kill the germ, it's don't kill the patient. Okay? I think that's more important. Let's look at technicians, okay? Who ordered a technician to his house in the past few months? Okay, to fix the air condition, to fix the refrigerator, anything. Internet, okay? And when a technician comes to your house and the bag is like messed up, okay? The tools like are rusty. And when this technician needs like a certain screwdriver, oh, I forgot it in the car. Okay, it's not professional. But when this technician comes to your house with an orderly bag, he has everything in place. Okay, does it require your help? It looks different. It feels different. And when he leaves your house, you say, wow, this guy is a professional. Or girl, however you, technician-ness, how do you say technician in, yeah, sorry. And as I hinted at the beginning of my talk, I used to be a scientist, a neuroscientist, and scientists are the same. Okay, we had a joke at the lab that an experiment went well because we wore the green shirt on the experiment day, and it was, of course, Tuesday, which is a great day for experiments. Okay, but that's a joke. But we had our discipline. Okay, let's say when you get into the barn owl's cage, you have to wear the gloves, you have to wrap your shoes with special covers, and this had a purpose, okay? Something that most people don't know about animal experiments is that you have to keep the animals happy. Okay, anyone knows why? What's the point of keeping animals happy in experiments?
I guess it's the same as with experiment with people. Don't believe that in worst state.
Yeah, stress. Yeah, stress destroys the data. Okay, it pollutes the data. You have to keep the animals happy. And most people don't understand and know that, but this is part of the scientific method Okay, we have the discipline. We have to work to follow some rules to achieve some goal. Okay, so our disciplines might be arbitrary. Okay, wax on, wax off. Okay, but who wrote them had an experience. The doctors, okay, someone, I think it was the 19th century, found out that in one hospital more patients died than in other, and the reason was that hand washing or something like that. I forgot the story, but it's a very famous story. Okay, so we can achieve the desired result. Okay, either to block the punch or less people die, or fix your refrigerator, depending on what you, on your profession. And this begs the question, what about our discipline? What do we do to prevent our customers from suffering from our, okay, remember, our job is to put bugs into the software. So what would prevent these bugs from coming to the customer, from interfering with the customer? Okay, and you might say, okay, I'm not a doctor, it's not life and death, but as we move along with software, our software can be anywhere. For instance, I worked on a project with JavaScript for a missile interception system. Okay, so this is life and death system. And your system, you can never know. You work on fintech, people rely on you to transfer the money correctly. It's life and death. Okay? So we need a discipline. Because I'm a scientist or a former scientist, I take a lot from science. I really love science. Philosophy of science was one of my favorite courses. And let's see how we can learn from scientists to become better at what we do. So in science, we raise an hypothesis. Okay? Let's say if we sit under an apple tree and an apple falls on our head, that means there's gravity, right? Is that a good hypothesis? So we design an experiment to prove this hypothesis. After we have the results, we match the expectations. Let's say we dropped it and it fell, we dropped it and it fell. That means we have gravity. And eventually, we have a discussion. In every scientific article, there is a discussion at the end. Either if the results were what we thought or not, we have some conclusion to continue our research. And another thing in science is that one experiment is never enough. Okay, in movies, you always see the doctor working on something, and then, especially in superhero movies, they like, okay, so I'm gonna try this on myself, and it's gonna work, and now I do this, oh, experiment succeeded, yeah, I have the answer. It doesn't work this way, okay? Scientific method is tiring, and you have to repeat every experiment a lot of time, and the more experiments you do with the same results, the more confidence you have in your, I'd say software, but sorry, your hypothesis. And after enough confidence is accumulated, it becomes a theory. Okay, and a theory is something other scientists can use to expand science. So, in software, we have an hypothesis. Our hypothesis is that a method or a property should act as we expect. We write an experiment, we write a test, and then we write the code, and we expect things to work all the time. Okay, if we expect a function to return false in certain conditions, it's supposed to return false every time we set conditions. We debug and refactor our code, okay, to make it look better, to explain how things work, or to fix if they don't. And the more the tests pass, okay, if our tests are consistent, we have confidence in our software. For instance, in our project, we have a project at work. We develop developer tools for Vonagem developers. So we're so confident in our code that we just ship it. Someone merges to main, and it goes to production. That's it. Okay, of course, there's code review before we merge, but we don't check it again. We don't have like a develop branch or anything. Okay, so you need to raise your confidence in your code. Yes, and we ship on Thursday, sometimes on Friday, sometimes on, we ship every day a few times. Okay, so confidence helps velocity too. So let's look at an example. That's my thesis hypothesis. I'm not going to tire you with that. But in software, it will look like this. Okay. Let's say it's a test in a function. Then this function should throw when the input is not an object. It's a pretty easy to understand hypothesis. And the test is also pretty easy to understand because we expect the function when its input is not an object to throw something. Okay, so we have an hypothesis, we have an experiment. Now we just need to run the function and make sure that it does that. So do we want to be a scientist? Okay, let's see how it happens. So I mentioned the hand washing and the technician with the bag, and the thing is that the disciplines are arbitrary, okay? What do I mean by arbitrary? These are rules that are created by experience, and I'm going to share some rules that I picked up along the way that help me make better software, better tests, more meaningful tests, but of course I'm going to share around 5 of them, but there are many more. So, as Roy mentioned, keep on learning also after the talk. So the first rule of testing for me is to test the public API. Okay, do not test implementation detail. A lot of times I hear developers, when I ask them, why don't you write tests? And they tell me, because I have to change the test every time I change the code. Okay, okay, so you probably wrote the tests wrong, but if you test your API, okay, that means that you test what your API is supposed to do, what your consumer expects your API to do, and, sorry, lost the track, and if it changes, that means that you broke the API, and it probably means you need to raise a major version, okay, Semver? Stuff. So this is the first rule. It helps you to keep the contract with your consumer, to document the contract with your consumer, because as you can see here, you can see all the properties that are open to the consumer, and if I'll open them, we'll soon get into it, the consumer can see exactly what every property, or let's say in this case, method, do. So this is the first rule. The second rule is to start with the simplest tests. Okay, this doesn't look like simple tests, but believe me, it's a pretty complex algorithm called Diamond Square. Anyone develops games knows what Diamond Square is? Okay, Diamond Square is an algorithm to develop create terrain maps or stuff like that, like maps in games. Okay, I'll send you the slides. There is a link to a blog post, I think, after that. Yes, you can go into this or await the slide. I wrote a blog post about how I write this algorithm in TDD. And the thing is that you should start from the simplest thing, which is usually input validation. Okay? And why start with the simplest thing? Because if you start from the main thing the function needs to do, you think too big. Okay? And then people say, how can I write the test without me knowing what the function is going to do? And the test becomes very bloated because you don't know exactly what's going to do, and then you test, and then you need to change it because it's coupled to the code. But if you start with input validation, which is very, very simple, then you start to build your function gradually. Okay, it just emerges from your code. So this is the second one. You can read this article. It explains actually everything I say today, kind of. just on this algorithm. Do you wanna, anyone? Yeah, I'll give you like 20 seconds. Anyone can hack Barry's watch to give me a few more minutes? It was fun. September, I've been to a conference when someone hacked into, I think it was Lemon, the scooter service. Do you have scooter service in Warsaw, like public scooter? So he hacked live to the scooter service, and he made all the scooters in a radius to ring at the same time. It was amazing. It was such fun to see that. And he said, yes, they have a loophole in their program. It looks so easy. Actually, I did it kind of like Roy showed you the HTTP request. So he just looked at the HTTP request of his phone, and then just saw that you can search in the radius, and it was, yeah, I guess people thought it was like ghosts coming to their town or something. Okay, cool. So while you're reading my, my article, the third rule of our wax on, wax off lesson is to mock for stability. Okay, mocking is a very debatable part of testing. People say, okay, I mock too much, then I test nothing. But the thing is that sometimes you have to mock. For instance, let's take this case. In the diamond square, there is a function that generates something random. Okay? But I want my tests to be stable. I want to know what to expect. So what do? I mock generate random for all of the tests and make generate random return something expected. And then all of my tests are stable. Okay? Can anyone see the problem with that? Yeah.
You do not know what's going to happen if something comes out of that random.
Cool. Okay, thank you. I'll repeat the answer. If I understand correctly, what happens if generate random is bad, right? Or in other words, how do I test generate random? Okay. So, was I correct? Yeah, I got it right. Yeah, I could say whatever you want. You're so far away, nobody here. Okay, so the thing is that we mock generate random for everyone else. And now, when we want to test generate random, we're going to mock the random part in generate random. Okay, because generate random is not creating something that's just random. It has some logic in it, and that's what I want to test. Okay, so in this case, I'm going to mock math random. Okay, to allow me to test the various the business logic of generate random. And this way, I have a tested generate random that everyone else is using. For everyone else, it's mocked, and my tests are stable. But it doesn't stop here, because math random is just an example for something that is like third-party app or third-party library. In this case, this is from real-life application I've built. We used Socket and Kafka in this app. This is Node.js in this case. And you can see that I created something that's called Socket Facade. Okay? And Socket Facade wraps my Socket IO. Okay, just like generate random wrapped my math random. And what I do is for the test of Socket Facade, I mock Socket IO, just like I mock math random for generate random. Okay, is that clear? Said a lot of names. Cool. Okay, it happens the same with Kafka. Okay, I have Kafka Node, which is a third-party library. I trust it because it's tested on its own, but I created a Kafka Facade. And for Kafka Facade, I mock Kafka Node, and for the rest of my code, I'll mock Kafka Facade to return stable and known things, and then all my tests will be stable. Okay. So after we finish waxing on and off, we'll go to the fence a bit. So another trick is to track sequences. Okay. For instance, we'll take the diamond square again. We'll go back to the diamond square. In the diamond square, for every diamond step, we have 4 square steps. That's the algorithm. Okay, I didn't invent it. That's how it is. So instead of testing the logic, okay, I first want to test that the sequence is right. So what I do here in this case, I create the sequence, and I create the expected sequence. Sorry. And then I just, I mock the diamond step. I don't care about its implementation. It might be that I didn't even implement it, because now I'm going to test the function that's calling
5 minutes, please.
The diamond step. I said hack his watch.
It was hacked, has been hacked successfully. 5 minutes, please.
Cool, 5 minutes, that's all I need. Okay, and then what I do, I hack them, and then I create a string that is accumulated during the run of the algorithm. And let's say I want to create the height map, which is the purpose of using the diamond square, with 5 tiles, okay? And I expect it to have like 5 sequences of diamond with 4 squares. And how does it look? This is the output of jest. And it's pretty clear what's wrong here, okay? I received only 1 sequence, and I expected to receive 5 sequences. Okay, so this is one trick, this is one nice trick to actually test methods that were not implemented, but test their parents. And sometimes you'd like to do the other way around, like depends if you're going from the smaller parts up or from top down. But this is a really nice trick that I enjoy using for sequence testing. The thing is that you can use inheritance for this. In JavaScript, it's pretty easy. So I just extend the original class and override the function. So here I can keep the original implementation and return the right string to follow the sequence. The final point is, maybe I started from it kind of, is to avoid the Holy Grail. Okay, and by Holy Grail I mean don't test what the function is supposed to do from the start, because then I find things like this in the code. Take a moment to read this, please. Okay, by the smiles I know who finished reading it. So this is from real 8-year-old code. So for 8 years, this code sat in a code base of a real company that's now, that went IPO, and, okay, because someone tested the Holy Grail, someone didn't understand that, and they just returned 5,000 for some test to pass. So start from small and gradually develop your tests and app. Okay. So we started with Disney Plus. From my experience, from my hard experience, from running shards back in 2007, and I hope that you now know a bit about the scientific method and how it compares to science, the software, to our software, and the thing is that I didn't mention it because sometimes it's frightening. But TDD, sorry, okay, I'm still alive. With TDD, it's much easier, okay? Because then you build things gradually, and you have your tests already, and they're decoupled from your code. But also, if you just follow these steps, you'll have better tests that don't break every time you change your code. And the final point is that these are my arbitrary rules, okay? But don't be afraid to formalize your own rules, because you all have experience in making software better, to make your code work better, to make your product work better. And don't be afraid to share these insights with others. It doesn't have to come from your managers. You can offer your managers a way to impact your whole team or even company by making better products. And this is the most important thing, okay? Don't write tests because they won't fail otherwise. But really, write tests, okay? Make your code better. Thank you.